This is ACT Math class. The topic that I'm going to cover today is number theory. The material that you can find it is from the Google Classroom. So if you go Google Classroom, there's one that indicates that ACT Math 1 number theory. That's something that you can download and look at it. And I strongly urge that you do these questions before I explain all this. Intentionally, I took out all the answer choices so that, it's going to be more difficult. Because this material is all about explaining about formulas. So I don't want you to rely on the so let's get started. So if you go page 2, it says number hierarchies. So the question that if you read, it says for every positive 2-digit number x with a 10th digit t. So one of the things that we can think about for this question is 2-digit number, and then 10th digit is t, and the unit digit is u. That is x. But then we cannot just put tu. It sounds like multiplication. So how we're supposed to put is, since t is 10th digit, we have to multiply by 10 and plus u times 1 as unit digit. And then reverse it. So if you reverse it, it becomes ut, which is u times 10 plus t times 1. That becomes the y. So this is y. And then the question is asking you x minus y. So x is now 10t plus u, and then y is 10u plus t. If you subtract these two, it becomes 9t minus 9u. So if it is in actual test, I mean, this is from the actual test as well, but you probably have answer choice. But one thing that I can recommend you to do is you can just, come up with whatever number. Let's say, instead of you putting tu, you just think it as x equals like 93, let's say. Then y equals 39. So if you subtract those two, then it becomes 54. And you can check, you can plug t and u. Oh, I'm sorry, this is t and u, and then you can just double check how it works. Okay. And the next question: what is the smallest possible value for the product of two real numbers that are differ by 6? So if you look at the question, two real numbers, which is x and y, and then it has to be differ by 6. So which means x minus y has to be 6. And then the question is asking you that, the product. So what is x times y is the question. And then, you have to figure out the smallest possible value for the product. So what is the smallest possible value of this is the question. The easiest way to approach this question is you can plug numbers in. Let's say x is 0, then y has to be minus 6. X is 1. The other one has to be minus 5. And 2, minus 4, 3, minus 3, 4, minus 2, 5, minus 1, 6, 0. Let's assume these numbers that, how it's going to be. If you multiply them each other, this one is 0, this one is minus 5, this is minus 8, minus 9, minus 8, minus 5, 0. So you can see the pattern that, oh, this is going down and up. So the answer is -9. The next question. The sum of 3 consecutive odd integer is k. As soon as you see like 3 consecutive odd integer, let's say the first number is n. Since it is an odd integer, you have to add 2 more. And then next one is 4 more. These are 3 consecutive odd integers. If you add all 3, that becomes k. So which means 3n plus 6 becomes k. Then in terms of k, what is the sum of 2 smaller of this one? So 2 smaller one is n plus 2, which is 2n plus 2. Using this form, how can you, like showing this 2n plus 2 in terms of k is the question. So then one thing that we can do from 3n plus 6 equals k, we can rewrite this one in terms of n equals. So which means 3n equals k minus 6. So n has to be 1/3 k minus 2. And then you can plug this n into here. So which means 2 times 1/3 k minus 2 plus 2. So if you organize it, it becomes 2k over 3 minus 4 plus 2, which is minus 2. So this is the answer. Okay, and then move on to next question. Next question is arithmetic sequence. As you know, arithmetic sequence is you're adding or subtracting the difference. That's why every time you add or subtracting, let's say a1 as the first term, and then second term will be a2, but then a2 means a1 plus, and a3 is a2 plus difference, but we can put this a2 into here, then it becomes a1 plus d plus d. So we keep adding d more. So then next a4 becomes a1 plus d plus d plus d. So which means we can see the pattern of once you put a1 in the beginning and then we adding d every single time. So that's why we can think it as general form an equals a1 plus 1 less than this n, you have to add, because the first term we don't count d, but then ever since then we actually adding d. So that's what the formula is. And then sum of this arithmetic sequence is Sn equals n over 2 a1 plus an. If you think about this example, you're adding 1 through 100. Without using literally like 1 by 1 calculating this summation, what you can do is, if you think about last 2 numbers, like out edge, if you add it up, it becomes 101. And then next to another 101. And then next to another 101. So the pattern is, every time you pair this up, it all becomes a 101. So how many pairs that you can have is half of it, which is 50. So you can think about, this answer for this question is 100 divided by 2 pairs times every time 100 plus 1, 101. So you can apply this question into this equation as a formula. So then, it's pretty simple. So going back to the question here, it says, what is the sum of the first 4 terms of the arithmetic sequence in which the 6th term is 8 and then 10th term is 13? So now we're just utilizing whatever formula that is given. So the first equation, an, so we have to use a first, so which is 6th term. A 6th is A1 plus 6 minus 1, and then D, which is A1 plus 5D, that is equal to 8. Then A10 is A1 plus 9D, that is 13. So now we have two different equations of this here. So to get the D first, we can subtract this 2. So then it becomes minus 4D equals minus 5. So D becomes 5 over 4. Once you get that, you can apply whatever equation here, so you can get the A1 as well. So which means if you plug like D into second equation, A1 plus 9 times 5 over 4 becomes 13. So A1 is 13 minus 45 over 4. So 4 times 52 minus this, so this is 7 over 4. And then now we have to use the summation formula. So which is, it says first 4 terms. I mean, you can actually try out after this. So since we know this is first term, you can add D 1 time and then 2 times, 3 times, whatever that you can do as well. Since you have a calculator, you can do. But the officially how you're supposed to do is using the formula. S4 is 4 divided by 2, and then A1 is 7 over 4 plus A4. But then A4 we don't know yet, so we have to figure it out. So which means we're using this formula A4 equals A1 plus 4 minus 1D, which is 7 over 4 plus 3 times D is 5 over 4. So altogether it becomes 7 plus 15, so 22 over 4, which is 11 over 2. So you plug 11 over 2 here, then you can calculate, it becomes 14.5. And move on to geometric sequence. The difference between arithmetic sequence and geometric sequence is, arithmetic sequence is you adding or subtracting, and geometric sequence you multiplying or divide. The formula is pretty simple. A1 and then A2 is A1 times the ratio R. 3 is you multiply another R onto A2. So A4, that is another R you multiply. So you see another pattern that, similar pattern that I just explained with the arithmetic sequence, which means when this number is 2, we multiply R once, and this is 3, we multiply twice, and 4, we multiply R 3 times. That's why if you just formulate it as a general, the formula, it becomes AN is A1 times R. How many times they multiply is going to be on exponent, which means N minus 1. That's why the first formula that you can see. And the second formula is, if you think about A1, A2 is A1 times R, A3 is A1 times R times R. So if you add this 3 up, it becomes A1 plus A1 times R plus A1 times R squared. So if you take out A1 out, 1 plus R squared. That is S3. But then if you think about this here, there's a formula that, 1 minus R cubed is 1 minus R times 1 plus R squared. So applying this to here, then 1 plus R squared becomes 1 minus r cubed divided by 1 minus r. So using this idea into this formula, which means Sn is now A1 times 1 minus r to the nth divided by 1 minus r. So this 3 is equal to this 3. That's how you can think, okay? And then now going to the question. The first and second term of a geometric sequence are n and an. What is 1,000th term of this one? So now n is the first one, so which means this, you can think it as a1. And then an, which means this one is now r. So the question saying 1,000th term, so a to the 1,000th that we have to get. So a1 times r to the n minus 1, so which is 999. And then you can apply this one into here, this n into here. You can apply a into here. So then n times a to the 999. This is the answer. I think they intentionally put a and n there because the formula itself is having same looking variable. So you don't need to worry about it. You just try one by one. It makes sense. Then you can choose that. And next slide is the geometric series. The simply put, geometric series means same as a geometric sequence, but then only about the sum. So then if it is finite number that you add, we use this one, S equals A1 times 1 R. But infinite one, S infinitely, you have to keep adding this geometric sequence is a little bit different because this part, R to the n gonna be equal to 0 because one of the condition of this one is R, absolute R has to be less than 1. So if you keep, let's assume R is 1/2, you keep multiplying 1/2, 1/2, 1/2, it keep, getting smaller and smaller. At the end, it becomes 0. That's why we don't need to worry about this part as a 0. Then the formula becomes A1 over 1 minus R. This question is quite popular in SAT or ACT, both of them. So it's good that you have to memorize this. So given question here, they give you the equation A over 1 minus R. This is really, really easy question if you have that the formula. But then even without knowing the formula, you have to know how to do this one. So the question says sum is 200. So sum itself is 200. And then common ratio is 0.15. So we don't know A1. And then we know ratio is this. So A1 is now 0.85 times 200, which is 170. And then our question is second term that you can find. So A2 is 170 times R, which is 0.15. Then it becomes 25.5. Move on to next question. Compounding interest. So compounding interest means you keep adding interest portion, onto the principal. Keep adding, keep multiplying, I'm sorry, keep multiplying the interest portion into the principal. So which is compounding interest is strictly saying the geometric sequence. So the given formula is there, so I'm not gonna explain all the detail, but one thing that I have to explain about is why it has to have 1 plus, and also why it has n there. So one of the things that you have to think about is, let's say you go to in a shopping mall and you buy a t-shirt. For the sake of simple calculation, let's assume tax rate is 10%, and the T-shirt itself was, let's say, $20, and then you have to pay tax, which is 10% of the price of the product. But if you factor this out, the 20 and 20 out, this is same as 1 plus 0.1. So any given question from the ACT or SAT as well, that it actually asks you that the percent increase, you don't need to like separate this out as a 20 plus 0.1 times 20. You just put it as a 1 point something. That would be much simpler. So another example is, let's assume, ignoring the tax rate, let's assume you have $20 T-shirts, but then you try to buy, you try to buy it, but then it was on sale, so 20% off. Then you have to subtract 20% of the product, price of the product. So then it becomes, if you take this out, 20 out, 1 minus 0.2. So basically, the percentage increase is add, decrease, subtract. That's why in this case, the compounding interest, what you see is adding, because it is increasing. Then how about this n? So those two n's are the one that how many times you're getting interest. So if it is once a year, then n equals 1. Twice a year, n equals 2. 4 times, which is quarterly getting, and then it becomes 4, monthly 12. That's something that you can think about. And then given question, it says consider exponential equation, blah, blah, blah. And then it says the value of y decrease as the value of t increases. If, and only if, which of the following statements A is true. Oh, the question is not really about compounding interest. This seems more about the geometric sequence itself. So if you think about here, the value of A, the question says that A is positive and constant, T is positive real number, the value of Y decrease. The value of Y decrease as the value of T increase. So then which number that you have to multiply to make it like less is Y equals C times A to the T powered. Then the total Y value has to decrease. That means C is constant, so you cannot change it, but this one has to be decreased. Then how can you make that, A of T will, A of T powered has to be decreased is A has to be less than 1. If it is less than 0, that's also, it becomes like, fluctuates because positive, negative, so it doesn't work. So that's why A has to be between 0 and 1. And then move on to next question. This is actually a compounding interest question. Jamal invested $1,000 on January 1st. At the end of 9th month, during the first break it down one by one. It says invest the $1,000. So principal is $1,000. And then 9 months. And then during the which made no withdrawal, no other deposit, the interest investment earned $75 interest. And then Jamal's $1,000 investment returned an annual percentage yield closest to which of the following percent? Since you're supposed to have the answer choices that you can just see, but then I just took out the answer choices. But then good thing about this one is this is compounding interest, but then this is continuous compounding interest, which means this is real time, what banks they use, so that the formula is given I equals PRT. So we can just utilize this one, that P is principle, basically. You have to put P as 1,000. And then now the question says initial money is P, and then R is annual percentage yield, which is interest. And then T is time in years. So then this is tricky part. This is in a year, so that 9 months out of 12 months is the one that we have to put. And I is also given as a 75. Now altogether 75 equals 1,000 times R times 9 over 12. If you like simplify, this is 3 over 4. So this is simplified like this, and then this becomes 750 R. So R has to be 10%. Then move on to the next one, absolute. So absolute value is something that you have to be careful about. When you take out the number inside of the absolute value, always you have to check whether inside the number has to be positive or negative. If it is positive, it will come out as just whatever number it is. Negative, you have to put negative sign on it. And a lot of times, students getting confused like this. Since it is, we all know that -2, absolute -2 is 2, but then they consider that as you take out this negative number, a negative sign out. But actually, what happened into here is you putting another negative in front of it, so it becomes positive. Okay, so you have to remember that you're putting negative sign in front of the question. So the question: what are the real solutions for x, if any, to the question this? If A and B are positive integers. So one of the things that we have to consider here is different conditions that we have to check one by one. Simply put, this can be 0, this can be 0. So absolute x is A, absolute x equals B. But then since absolute value is there, we can just think it as A, x has to be plus minus A. Also, x has to be plus minus B. That's what you can put. But if I can go one more step, this condition is when x is greater than 0, it becomes positive A or equal to 0. X is less than 0, it becomes negative A. Same as B as well. Okay, move on to the next question. Solution set of which of the following equation is the set of real numbers that are 5 units from -3. So this is a good example that you have to memorize in a way. Like this is the one of the question lots of students end with. So whatever my suggestion is, distance. If you have something that the distance 5 units from -3, that means you have to just come up with, oh, this is an absolute value question. And then the setup is within the absolute value, you have to put the original condition, which means x plus 3. Because it says from -3, the root is x is -3, then you have to, make it as x plus 3, because x plus 3 equals to 0. That's how you're supposed to do. And then that is, the distance is 5. That's why you can just put it as this right here. Okay, and then move on to the next page. Now A is less than B, and then absolute A minus B is equivalent to which of the following? So if you look at the A is less than B, then if you think about inside of this value, which is, since B is greater, this inside is less than 0. So as I said earlier, if inside of the absolute value is negative, then what you do is you put negative sign in front of it. This is the answer. Least common multiple. We have GC, greatest common factor GCF or LCM. GCM is not really a popular question in the, but the LCM, it does come like quite often. So how you're supposed to think about LCM and GCF is, this question is, the given question is pretty simple. 4, 6, 8. Oops, 4, 6. Then you can just factor this out first. 2 and 2, the prime factor, and 2 and 3. And then this is 2, 4, 2, 2. So then you can see that, the first one has 2 2s, and second one 2 and 3, and third one is 3 2s. So to make LCM, you have to have all the common the factors together, and then adding whatever unique factors that this each number has to have. So starting off of 2 times 2 first, like this one, and then the second number, if you see 2 times 3, it is okay for 2 because already included here, but then 3 is not there, so that we have to multiply 3 here. The third number, first 2 okay here, second 2 okay here, third 2 not, so you have to multiply here again. So this is how you're supposed to do with the LCM. So the answer is 24. Factor theorem. So if you see the questions like this, how you're supposed to do is always there's two different theorems, factor theorem or remainder theorem. Both of them are same idea. So which means, let's assume you have f of x, then something is divide this f of x, and then you have quotient, and then remainder. If it is remainder equal to 0, that is factor theorem, because it's factorable. But then how can you get the whatever this this is not K, this is K. Whatever this this is, whether this is factorable or not, is you can just plug any number, the whatever root of this one. So x minus a, so x equals a. Then if it is factorable, remainder, since remainder is 0, this one becomes 0. So then f of a equal to 0 is whatever you can think it is. But then the question saying, oh, there's a remainder, then different story. You have to put, a, and then you have to come out as like whatever remainder. So that's like a little bit different question. But then this one is about, just factoring itself. Now, this is factorable by x minus 7. So maybe you can use synthetic division, which is 2, negative 11k. Oh, this is 7. So 2, 14, 3, 21, k plus 21 equal to 0. That's one way you can do. And another way is, as I said earlier, f of 7 has to be 0, which means 2 times 7 squared minus 11 times 7 plus k has to be 0. Either or is fine. And then one more question about this is, polynomial x squared minus kx minus 30 is product of binomial this and another binomial. So x squared minus kx minus 30 is product of this 2. So as I said earlier, this is another case of the factor theorem, because since we don't have remainder, that means you can just simply plug negative 5 into here. Then you're going to have 0. So negative 5 squared minus k, negative 5 minus 30, that becomes 0. So 25 plus 5k minus 30 becomes 0. 5k equals 5k has to be 1. This is one way you can do, and the other way you can do is same synthetic division you can do too. Okay. Today, I mean, you know, I cover half of this the slide that I posted up. So I'm going to cover next half for next the video lesson. Okay. So thank you for watching, and then we'll see you soon. Okay.